integration by partial fraction case 4, we have repeated irreducible quadratic factors. Take a look at the function I gave you, phi divided by a bunch of factors, right? So the first one, x is linear, x minus 1 is linear, but they are not repeated. And then here comes with the problem. The x squared plus x plus 1 cannot be factor, so I call that irreducible. Irreducible means cannot be factor, but it is not repeated. How about the last one? The x squared plus 1 cannot be factor, so you call that irreducible, and that repeated 3 times. For the no repetition, we discussed that in case 3, right? In case 3, we discussed irreducible quadratic factors. However, they are not repeated. So when they are repeated, then that will be case 4. So this is a gigantic problem. So let me show you how to do the partial fraction. I already color-coded everything for you. So we have phi divided by all the factors. So the first one, x is linear, no repetition. So we use one letter for that, a divided by x, and then the x minus 1 in orange, that is linear, no repetition, use one letter for that, b divided by x minus 1. And then the irreducible. The irreducible cannot be factor. Every time you see a irreducible quadratic factor, you have to use 2 letters, which is C and D. And here comes with the trouble. The last one is irreducible and it repeated 3 times. So if for no repetition, we use 2 letters. So for the power 1, we have power 1, power 2, and power 3. So power 1, we have x squared plus 1 raised to the first power, and then on the top, we have ex plus f, 2 letters. And then for the second power, we use another 2 letters, g and h. And then for the third power, we use another letter, I and j. This is the hardest case ever because the system, when you equate the coefficient and then solve the system is going to be gigantic. It will take forever to solve the system, right? So when you see this type of problem, it can be super difficult, and hopefully you don't see that on a test. Homework is fine, you have all the time you want, but on a test, I hope that you don't have this type of problem on a test. When I write a test for my student, I usually give a problem either from case 1 or case 2. Okay, I prepare a problem for you. This is the best problem ever for discussion. So the integral looks simple, 1 divided by x to the third minus 1 dx, right? And how do you get the get the factors? By the way, you might say, okay, we don't need to get any factors. The x to the third minus 1 is already a factor, right? You might ask me this, hey, why do we need to factor that? This is already one factor. Is the x to the third power quadratic? The answer is no. So x to the third is not quadratic. Then we have to factor this. I have 2 formulas on the right. One for the minus, one for the plus. You study that in algebra, but you don't use that very often. So I think it is a good idea to mention that right here. Okay, we have a third power. So b is equals to 1. Let's factor this. So we have 1 divided by a minus b, x minus 1. And then we have x squared plus x plus 1. All right. And then what's next? So this is a dx. And then which one is quadratic? The square, right? But that is not, but you might say, hey, that is not repeated. You're right, that is not repeated. If I put a second power in here, that will make the entire problem gigantic, right? So if I put a square in here, you have a, you have a BC, and then you have a DE. That will make the entire problem very gigantic. So let's don't put the 2 in there. Okay. And then we do the partial fraction, 1 divided by x minus 1, and then x squared plus x plus 1. That is equals to a divided by the linear factor, right? One letter only, and then plus bx plus c divided by x squared plus x plus 1, And then, oh, by the way, if you want to practice, so here is how you do it. If you want practice, you can put a square above that, then that will be as a, b, c, and then we will have to use d and e. Then that there is a dx plus e divided by that, and that problem will be gigantic. I don't want to go into that. Using the bx plus c, this problem is meaningful enough to make a discussion. Trust me, as we move on, you will see why I picked this problem. It is such a good problem, and it's a fair problem to put on a test. Okay, let's get rid of the dx and e. So we have some good stuff coming up. So the next step is get a common denominator. So 1 is equals to a. I need the long one, so x squared plus x plus 1. And then for the bx plus c, we have x minus 1. All right, and then this one, can we use convenient numbers? The answer is yes. So if you let x equals to 1, the bx plus c will be gone instantly. So you have 1 equals to a times 1 plus 1 plus 1, so that is 3. So a is equals to 1/3. I still don't have b and c using the convenient number, but at least the 1/3 will help me when I do the system. Okay, let's do equating the coefficient. Oh, before that, we have to open up everything. So 1 equals to ax squared plus ax plus 1, and then plus bx squared minus bx plus c minus c, right? Plus cx minus c. And then we group all the powers together. So we have a second power, and we have a first power. So this is a first power, and these two are the first power. And then we also have a constant. The one without underline is constant. So on the left hand side, I have 0x squared, right, plus 0x plus 1. And then that is equals to a plus b, take the x out, and then a minus b plus c. This will just take a little bit of practice. Take the x out, so you can do this in one step. Plus 1 minus c. Oh, by the way, that is a. This is a, not 1. A minus c. All right, and then you equate the coefficient. So the 0 goes to a plus b, and then the second 0 goes to a minus b plus c, and then the constant, the 1, that goes to a minus c. Okay, let's do the setup. So this step is called equate the coefficient, right? Equating coefficient. So first, we have a plus b equals to 0, a minus b plus c equals to 0, and then a minus c is equals to 1. We got a already. So this is a 1/3 plus b equals to 0. So I know b is equals to negative 1/3. And then I got a. So we have 1/3 minus c equals to 1. So 1/3 minus 1 equals to c. So c is equals to negative 2/3. Now I have a, b, and c. So let's plug in a, b, and c back to the very first line to do the integral. So we have a over x minus 1. Then, let's do it right here. A is 1/3 divided by x minus 1 dx, and then plus bx plus c, negative 1/3 x minus 2/3 divided by the irreducible x squared plus x plus 1 dx. And this integral isn't that easy to solve, and that's why I picked this problem for our discussion. So the first integral, easy, it's just 1/3 and then ln, absolute value of x minus 1. And then the next one, I would like to factor our 1/3. So there is no more fractions on top, so this will be x plus 2 divided by the irreducible factor dx. And then most people might say, hey, let's try u substitution. U equals to x squared plus x plus 1, and then du equals to 2x plus 1, and then dx, you can do this, du equals to 2 x plus 1 dx. Well, that is not going to get rid of the x plus 2. Oh, one half. That is not going to get rid of the x plus 2. Okay, then what do we do then? It looks like we are stuck, and you cannot use the partial fraction because this is not reducible. So the way we do this, listen to me right now, and that's why I picked this problem. And I know it is not obvious. That's why I picked this problem to discussion. After the discussion, now it is obvious to you. Okay, let's do the works. I am going to do some magics on the 2. What kind of magic? I'm going to let 2 equals to 1/2 plus 3 over 2. All right, so with the x, I have x plus 1/2 plus 3 over 2. And then I will break this down into 2 fractions. Okay, so we have 1/3 ln absolute value of x minus 1. Let's do the breakdown. 1/3 integral x plus 1/2. And then divided by x squared plus x plus 1 dx, and then one more, the negative 1/3 integral 3 over 2, because this goes here, and then this goes here, x squared plus x plus 1 dx. Okay, now do you still remember the result of the u substitution? And then this x plus 1/2 will get rid of this x plus 1/2. All right, and then leave you a 2 out front. So we have 1/3 ln absolute value of x minus 1 minus 1/3, so that leaves you a 2 out front, the 2 in front of the 1 plus 1 over 1 over 2, x plus 1 over 2. So we have to multiply 1/2 and then integral 1 over u du. This is taking the benefit of the u substitution. And then what about the 3/2? The 3/2 and the 3/2, we have to do some works for it. So we have to do completing the square. Complete the square. So we have to do x squared plus x and then save some space, and then we add 1 to it for the quadratic equation. Ax squared plus bx plus c, right? So the coefficient of b is 1. So to complete the square, you have to take the coefficient of the first power divided by 2 and then square. So that is 1 divided by 2 square, and then do not square this for me. I know that equals to 1/4, but please don't use 1/4. You add this extra quantity and then subtract the same quantity immediately. So for the first 3 terms, we can take that as x plus 1/2. Since this is a 1/2, we put it right here. The square goes outside. 1 minus 1/4 is 3 over 4. And then the result goes up there. And then how do I write this? Okay, let's do this in orange. Minus 1/3 and then integral 3 over 2 divided by x plus 1 square plus 3 over 4. Okay, so let's do the purple. So we have 1/3 lavender or purple, x minus 1 minus 1 over 6, and then u equals to what? U equals to the irreducible, so that will be ln absolute parenthesis x squared plus x plus 1. Because this is guaranteed positive, I don't need to worry about the absolute value. And then we have to take care of the last integral, the orange integral. So for the orange integral, we have to recall another formula, that is the integral 1 divided by x squared plus a squared, that dx, that is equals to 1 over a, and then inverse tangent x divided by a, and then plus c. So in this integral, we have x is actually equals to x plus 1, the whole thing inside the parenthesis. And then the a is equals to the square root of 3 over 4, which is root 3 over 2. Because once you square that, you get the 3 over 4. All right. And then the result is, let's go back to orange. So this is minus minus 1/3, right? Minus 1/3. Did I make a mistake on the 1/3? Nope. So minus 1/3. And then we have 1 divided by a. So 1 divided by root 3 over 2. And then inverse tangent x divided by root 3 over 2. And then plus c. Oh, the x, that is not an x. That is supposed to be x plus that is supposed to be x plus 1/2, right? Oh, I roll 1, huh? Too many numbers. 1/2. So this is plus 1/2. All right, plus c. And then the final answer is right over here. It's a long problem. A lot of work, many numbers, extremely easy to make mistakes. That's why I picked this problem for our discussion. If you want to practice the system, just simply start right here. Just simply start right here and then change that to a square. So that you can practice solving this. That problem should be gigantic. Okay, you can try this at home. I'm not going to try this on my video. So that is the end of this problem. If you think my instruction is clear and helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel. See you all in the next one. Signing off for now.